Hey guys, Mr. Martin here again, back with our last video in Unit 2 called Angle Pair Relationships. Let's get started. Alright, the first angle pair we're going to talk about is a pair of right angles. This theorem says something that we consider to be pretty obvious, but again, we have to state everything even if we consider it obvious. This theorem says if two angles are right angles, then the two angles are congruent to each other. Very simply, it just says all right angles are congruent. We use this theorem in order to reduce the number of steps you need when we're using a proof involving right angles. So let's look at the proof of this theorem. When you prove a theorem, we're going to write the hypothesis of the theorem as the given statement, and then we're going to use the conclusion as what we must prove. So again, this theorem says if two angles are right angles, then the two angles are congruent. So let's look at a proof of this theorem. Okay, so we've got two right angles. Angle 1 and angle 2 are right angles. They want us to prove then that the two angles are congruent to each other. Okay, so let's look at the first statement we know is always going to be given, right? Let me spell that right for you. Right? All right. The second statement says that the measure of angle 1 is equal to 90 and the measure of angle 2 is equal to 90. How do we know that? That, of course, comes from vocab. We know what a right angle is. Remember what I said? When we use a vocabulary word, we always have to define it in our proof. Okay? So now we've got the measure of angle 1 equal to 90 degrees and the measure of angle 2 equal to 90 degrees. Anytime we have two different things equal to the same thing, in this case they're both equal to 90, we can set them equal to each other thanks to the transitive property. Yep, that's right. Okay, so I'm just going to put transitive prop. Is that all right? All right. Last one says if we know that the measure of angle 1 equals the measure of angle 2, we know that the two angles are congruent, and that comes from the definition of congruence. We know what it means to be congruent. For angles, that just simply means the two angles have the same measure. Okay? So there we go. Kind of an obvious proof, I think, but it is again one that we always must explain for anybody reading a proof. We cannot just assume that everybody knows these kinds of things, even if they seem obvious to us. Alright, let's go on to the next pair of angles. This one is called the congruent supplements theorem. So now this time, if we have a pair of angles that are supplementary to the same angle, then they are congruent. So in this case, we have angles 1 and 2 are supplementary. These two are supplementary. Okay? But in addition, we also have angles 2 and 3 are supplementary. So these two angles are supplementary. So what the theorem says is if they are supplementary to the same angle, then they must be congruent to each other. Again, let's look at a proof of this. I think the theorems become a little bit clearer when we actually prove them. Alright, so this one says angle 1 and 2 are supplements. Angle 3 and 2 are supplements. Prove that angle 1 is congruent to angle 3. So the first statement in our proof is always the given information, and our reason is always going to be that that was given. Okay? Second one says that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 3 and the measure of angle 2 equals 180 degrees. Again, we used vocab. Anytime we use vocab in our proof, we are going to define it. So this is definition of supplements. We know if they are supplements, the measure of their angles equals 180 degrees when you add them together. Alright? So this looks very similar to the proof of the right angle congruence theorem. This now says we've got two pairs equal to the same thing. Obviously, both equal to 180, then they must be equal to each other thanks to the transitive property. think you guys can see how useful that transitive property is now because we've used it in a lot of proofs already. Okay? Now look at statement 3. It has the measure of angle 2 on both sides. So can we just subtract that from both sides? I think we can, thanks to the subtraction property of equality, which says as long as we subtract the same thing from both sides, we preserve the equality. Okay? And then lastly, if their measures are equal, we know that the angles must be congruent, thanks to the definition of congruence. I hope these proofs are getting a little bit easier for you. We're proving some pretty easy stuff right now. The idea is that going through these proofs of the easy stuff will help you prove the stuff that's maybe not so easy. Alright, let's go to the next one. We just had the congruent supplements theorem. Now we've got the congruent complements theorem. Okay, this one says if two angles are complementary to the same angle. Okay, so 4 and 5 are complementary. Okay, and also 5 and 6 are complementary. Okay, so we've got two different angles complementary to the same angle. This theorem says if that's true, then those two angles must be congruent. The proof for this theorem looks very, very similar to the proof we just did. Instead of using 180 degrees, though, we're going to use, what's complementary again? That's right, we're going to use 90 degrees, okay? So right here, the only difference in the proof is that they're both equal, the sums are both equal to 90 degrees. So reasons should look very similar. First one was given. Second one is definition of complements. The previous one was definition of supplements. Okay? Alright, I want you to pause the video right now and I want you to fill in the other ones, okay? Let's go ahead and pause the video. Alright, did you get the same thing that I got? The transitive property, the subtraction property, and the definition of congruence? I hope so, because that's very similar to the proof that we just did on congruent supplements. Alright, let's take a break from these theorems and look at a postulate. Okay? Remember, postulates are things that we accept without proof. Okay? This is one, again, that I think you're already familiar with, but we're going to, again, make it formally defined. Okay? This time, we're talking about the linear pairs postulate. It just says if two angles form a linear pair, then they are supplementary. Remember, again, we've got the word linear, meaning they form a straight angle or a line. Okay? So that's one that we just accept. We're going to use the linear pair postulate to help us with vertical angles. Let's look at the vertical angle congruence theorem. Okay? If you remember back in our definition of vertical angles, we said that vertical angles are two angles whose sides form opposite rays. So for example, let's look at angle 1 and angle 3. The sides of angle 1, namely here, right, form opposite rays with the sides of angle 3, down here. Okay? The opposite ray from one of the sides of angle 1 is one of the sides of angle 3. And the other side of angle 1, its opposite ray, is the other side of angle 3. That's why we call those vertical angles. So we know from before that the measure of vertical angles are always going to be equal to each other, or we could also say that vertical angles are congruent. All right, let's again look at a proof of that, and we'll use the linear pair postulate to prove the vertical angles theorem. Alright, so the theorem says that if angle 5 and angle 7 are vertical angles, they want you to prove that those two angles are congruent. Okay, so let's start off with, obviously, I don't have to tell you this, but I feel like I want to just repeat myself again. The first reason is always given. We always bring in a piece of given information. In this case, we only have one piece. Okay? But we always bring that in, and the reason is always that it was given information. we got to start somewhere in the proof, and we start with the given information. Okay? All right. Now, how about 5 and 6, and 6 and 7 are linear pairs? How do we know that? How do we know that 5 and 6, if you can't tell, I'm a big fan of purple, okay, and 6 and 7 are a linear pair? Okay, once we know we got vertical angles, okay, we can tell from the diagram that 5 and 6 are a linear pair, and so are 6 and 7. We know this because we know the, what is it? Yep, we know the definition of a linear pair. In other words, we can tell from the picture that the two angles, 5 and 6 and 6 and 7, are a linear pair. Okay? All right. Now let's go on to statement 3. How do we know if they're a linear pair that they are supplementary? Well, we just talked about that. That comes from the linear pair postulate that says if two angles are a linear pair, then they are supplementary. Good. Okay? Now, we just have the, remember the process that we just did with the congruent supplements? We say if two angles are supplementary to the same angle, and again 5 and 7 are supplementary to angle 6, then they must be congruent to each other. So this comes from the congruent supplements. And an abbreviation I like to use for theorem is THM. Okay, so you could have actually used the congruent sign, okay, and then put sup and then THM, and that would have been an okay abbreviation for that theorem. Okay, we're almost done, guys. I know we're going on 12 minutes now, but want to finish up with just one example of how we use the linear pairs postulate and the vertical angles congruence theorem to find the measure of some angles. All right? All right, so now we've got a diagram here with two intersecting lines or two pairs of vertical angles. Okay? And they tell us that angle 1 is 112 degrees. Okay? Let's use a different color since those numbers are already in red. I won't use purple again because maybe you're getting bored with purple. But let's go with 112 degrees. Okay? So there's a lot of different ways we can tackle this. We know we've got a linear pair here, right? So we could say that those are supplementary. But we also have a pair of vertical angles as well. So either way, we can figure out what angle 2 is, or we can figure out what angle 3 is. But let's use the linear pair postulate, okay? It says that the measure of angle 1 plus the measure of angle 2 has to be 180 degrees because they are a linear pair. So if we know that angle 1 is 112, then we can very quickly, oops, that's angle 2, let's fix that, angle 2, okay, must be, let's just get rid of the 112, so we can see that the measure of angle 2 must be 68 degrees. Okay, that's one way we can do it. We can put the 68 degrees here, okay, or another way we could do it was we could say that because we know that angles 1 and 3 are vertical angles, we could say that the measure of angle 1 must equal the measure of angle 3 because we know from the vertical angle theorem that those two angles have to be congruent or their measures have to be equal. So we could take out angle 1 and put in 112. Then obviously, thanks to the symmetric property, we could flip that around and say the measure of angle 3 must be 112 degrees. So this must be 112 degrees. Okay? And then for angle 4, we can do something very similar. We can either use vertical angles and say that 4 and 3 are vertical, or we can say that, that's right, 3 and 4 are a linear pair. Either way, we're going to find out that angle 4 must be 68 degrees. So I think you can tell from the picture on vertical angles, the angle pairs are either going to be supplementary, meaning they're going to equal 180 degrees, or they're going to be congruent, or their angles are going to equal each other. There's really only two choices there. So when we draw two intersecting lines, the angle pairs are either going to be, okay, either they're going to be supplementary thanks to the linear pair postulate. Oops, let's spell that right again. They're either going to be supplementary or, thanks to the vertical angles theorem, they're going to be congruent. Okay? So you only have two choices. So if you're going to guess either congruent or supplementary. Hopefully you see that the linear pairs are supplementary and the vertical angles are congruent. Alright, you guys, I know we went a little long today. This is probably going to be one of the longest videos we've ever done because we just had so much to cover. But in class, we're going to talk about these theorems and use them to actually find the measures of angles. Alright, again, make sure you got good notes, and we'll see you in class on Tuesday ready to tackle these in actual examples. Talk to you later.